So to calculate the third length of the triangle, since we got a right square triangle, whose theorem we're going to use? Pythagoras.
Yeah.
So what was that equation again?
A
squared
squared.
plus b squared equals c squared.
Okay. In other words, take the sides of your shortest triangle, two shorter sides.
Is that plus or?
It's equal. I stuttered. Take the two shorter sides, square them, add them together, and then you get the square of the longer side. So what's 10 squared?
100.
Is 100. 18 squared?
324.
324. So this is going to be the square root of 100 plus 324, which is the square root of 424. Okay? So when we leave our radicals in exact form, 424, but can we simplify that? How?
Square root.
No, simplify does that mean just take the square root of one decimal answer?
Oh!
You need to practice on simplifying your radicals.
Oh no.
You know, like that's 4, and it's 206.
So here I'll do it up here. Square root of 424 is the same as what?
20.
4 times 106.
No, I don't know what's 106. Oh yeah, 106.
106 you can't break down any farther, right? It's not divisible by 4. It's not divisible by 9. Not divisible by 25,
2 and 106.
right? So square root of 4 times the square root of 106. So that gives us 2 106.
On a tester, you have to show her to work for that.
To simplifying the radical?
Yeah.
No.
No, I didn't.
You leave it like that. You just
So by exact you mean that, and I just.
Yes, so that this is the exact form is you're leaving it as a radical. You're leaving it as a square root of something. You have to simplify on a test. Okay?
Math. I like math. I really like this unit.
Okay? So now I'm going to do the angles. I'm going to do the angles. Dale,
opposite over adjacent.
opposite of what?
And
What are we
use
talking
the right angle.
You do this angle? Okay.
The
So
opposite,
we'll call this theta.
theta, the opposite is 10. Adjacent
Okay, well what is the opposite?
the opposite side of theta.
Okay, but what trigonometry function are you talking about? Yes. So you're doing tan of theta is opposite over adjacent. So tan of theta is, in this case,
10 over
10 over 18.
Is this still have the when you were drinking before?
Sorry.
No, you're not. So tan of theta is 10 over 18. So in order to get theta by itself, we want to solve for theta, right? So we need to do the opposite of tan, which is,
10 inverse.
remember?
Negative.
No,
Tan
10 to the power of negative 1.
Isn't that the inverse?
the opposite of tan is bleach.
Oh gosh.
Yes, the opposite of tan is tan inverse.
I was scared.
Alex will do that on test.
So tan theta, so the tan inverse of 10 over 18. Do I need to simplify this here? Do I need to simplify 10 over 18? No, it's not my final answer, right? So there's no point going through that when it's going to do 10 divided by 18 and take the inverse tan of that. So what's beta? What's the inverse tan? 29? So 29.05. So here we're going to say theta is 29. 29 degrees. So if this is alpha, how do we get alpha?
Get 180, subtract 90.
Yeah, so we know that all degrees of a triangle, all the angles up to 180. Right, so 180 minus 90 is 90, minus 29 is 61. However, I will caution you that given the calculator work that I've seen all my students do, I highly recommend that you do this another way. If you put in, for whatever reason, you mishit 10 over 18 and you hit 1 over 18, you miss hitting that 0. And you do the inverse of tan of that. So what's the inverse to tan of 1 over 18? 3? So around 3 degrees, 4 degrees. And then you say, well, the other one's going to be 86. I'm not going to give you marks for the other one. I will only give you 1 mark for the buggy 4 degrees, but I'm not going to give you marks for the other one.
Show your room from home.
Just be safe, do the tangent of the other one. Okay? You know already that, if your 29 is right, you know it's going to be 61. So you know that, right? Based on this 180. So just take the extra step of saying, you know what? Here, the tan of alpha is what? Opposite over adjacent still. So tan of alpha is 18 over 10. So just do 10 divided by 18 divided by 10 and do the inverse tan of that. What do we get? Did you get 61? Okay, like a 30-second check almost, right? That you didn't make this mistake over here. Because chances are you're not going to make the same mistake on the calculator twice, especially if you're working different numbers, right? Obviously now you got a number that's different than 61. You got 59, 34. Red flag should be going off. Whoa, I did something wrong somewhere. That's how you get easy marks in math, right? Just little self-checks that we just take a little bit of time to do, okay? I'm not saying you have to do it this way, right? If you're pretty accurate with your calculator, you're pretty confident, you get 61, it's good. Okay, but if you don't get it right here, I'm going to be less lenient over here. Okay, just because you didn't take the extra time to check.
I think it's faster than Jack.
Pardon?
I think it's faster than Jack. My addition is correct. Just saying that.
Yeah, you Mr. Trusty Calculator over there. You hit the calculator correctly all the time. Okay, notes. So I'm going to teach this thing called SOHCAHTOA.
This is the rap.
Why?
Oh, yeah. I know.
Is it a rap? Is it a rap? I don't know.
What do you put on the back one?
Okay, I didn't listen to it, sorry. So February, does it have to be in all capitals? Doesn't have to be in all capitals.
It's just saying the concept.
Okay.
SCT.
To be honest, when I first heard of this, I thought it was like an Indian word. Some Indian mathematician out there, right, from this tribe, well, it's like SOHCAHTOA. So how you pronounce it? So, S-O-H, so, ka, C-H, SOHCAHTOA. SOHCAHTOA. Okay? So here we have a triangle that I introduced the tan ratio with, right? So we have a right angle triangle, we have theta, we have opposite is 6, adjacent is 9. So let's do the review of what's tan. So this is theta. What's tan of theta? Well, it's opposite over adjacent. I'm gonna write this out. Opposite over adjacent,
Toa.
right?
Tulen.
So in this case, it's what's the opposite of theta? 6 over 9. So that gives us 2/3. Okay. Actually, before I get there, let's just figure out the length of that third side through Pythagoras theorem. So 9 squared is 81. 6 squared is 36. square root of 81 plus 36. Okay, I caught this a lot when you guys were doing the quadratic formula. Make sure your square root goes over everything that's supposed to be the square root of. Alright? Or else that's technically incorrect. Right? I mean, this is very different than square root of 6 plus 3. Right? This is 9. This is 3, and this is, I don't know what that is. Square root of 6 plus 3. Very different things. So when you do your square root, let's be careful with what we're doing in terms of that line. So that's equal to square root of 117. You know you can simplify that? The 3 square root 13. 117 is divisible by 9. It's actually 9 times 113. So square root of 9 is 3. So 3 root 13. That's the length of the third side. You okay there? What did I
A little confused.
on how I got this?
Yeah.
Square root of 17?
Yes.
So square root of 17 is I got 81 plus 36.
117.
Sorry, what did I say?
17.
117. I got that from 81 plus 36. And that's because I did 9 squared. So I'm doing the square of this side. So 9 squared is 81. 36. So basically I was doing a squared plus b squared is equal to c squared.
So it's just Pythagorean.
Yeah. Right, so I just took this squared, which is 9 squared is 81, added to this square, which is 36, and then taking the square root of that, which is 117. So I'm going to introduce the 2 other trigonometric functions for the rest of the unit. This is all unit 7. Done.
That's it.
We're done.
Like new things or?
So we know that tan was a certain ratio, right? Tan was the ratio of opposite over adjacent. Sine is another ratio of theta. So same angle, okay? Do this in black. So sine is still the opposite side.
Over hypotenuse.
Thank you. But we did it by the hypotenuse.
Ooh.
How did you know this?
Ooh. Because it's so
Okay?
What?
So sine of theta is the opposite side over hypotenuse, that ratio. Okay? So that ratio for theta will always be the same because due to our similar triangles. So same idea with the tangent,
That's
now we're just doing sine.
So Kato is not.
It's not
Wow,
we made it a word.
tricky.
Okay? So here, what's the opposite side of theta?
C6.
6.
Right? The opposite side of theta is still 6. What's the hypotenuse?
3.
3 root 3. It was 3 root 13, right? So that could be simplified to be just over 2 over root 13. Okay? So for theta here, right? Actually, humor me. Somebody calculate theta for me. So what's the inverse tan of 2/3?
Calculator away.
Have to text me the password.
So what is that password?
32.7.
Yeah.
Yeah.
6891.
6891? So 32.7.
It's 33.7.
33.7?
32.7, yeah. Yeah.
Okay. So now take 2 divided by square root of 13. Okay, so that's what we said the sine of theta was 2 over. So take 2 divided by square root of 13. What do you think the opposite function of sine is?
Inverse sine.
inverse sine, which is sine negative 1. So find out on your calculators, what do you get?
What was it do again? Sine?
So sine inverse of 2 divided by square root of 13.
33.75.
33.7 still.
I have 33.
Who? 33.
Show me on it.
Yeah, it should be the same as the other one. Okay?
Oh.
So you can get beta if you know if you know all three sides. You can get it through different ways. So cos of beta, again, is just the last ratio. Here, instead of opposite, we'll look at it's the adjacent side over the hypotenuse. Actually, I forgot to abbreviate this. Sine of theta, you can say is opposite over hypotenuse, O over H. So cos of theta is A over H. Adjacent side over the hypotenuse. So that ratio. So here in this case, what's the adjacent side? For theta? 9. What's the hypotenuse? Still 3 root 13. So we can simplify that, and we get 3 over square root of 13. So now if you do cos inverse cos of 3 divided by square root of 13, do that on your calculators? Do that on your calculators?
Like, has your question?
Cos inverse, do your calculator first, of 3 divided by square root of 13.
33.7.
33.7.
I don't know. I don't understand what sin and cos is. Is this like another way of figuring out what that?
So again, what was tangent?
Opposite over adjacent.
Tangent is your ratio of the opposite side over your adjacent side, right? So given this degree is 33.7, right? No matter how big I make this triangle, right? If it's this degree, this angle is 30.7, this ratio opposite over adjacent will always be 2/3. Always be 2/3. No matter how long I make this side, no matter how long I make this side, as long as I keep 33.7 over here, this side will that ratio will always be 2/3. So now we discovered the sine of that angle is really it's another ratio, opposite over hypotenuse. Right? Because we discovered that once we have similar triangles, all the ratios of the sides, they all come up to the same. So we're just doing it off of reference to this angle now, which is all basing off of this angle. So all sine is just your opposite side over your hypotenuse. That ratio will always be the same. Cos is the other ratio of adjacent over hypotenuse. Okay? So all three trigonometric functions are just ratios of sides. And you get this value. But the thing is, the nice thing about this, the real key to that is, if you know your lengths, you can get the angle through the inverse function. Just exactly what we did here. Right? It's a lot easier to measure the length of a side than it is to measure angles. Okay? Any questions on that? So what's SOHCAHTOA is coming from?
Sorry.
Okay. Don't shoot me, I'm just a messenger.
I'm supposed to cut.
So what SOHCAHTOA is coming from? So the SOH, that's really, it's short for sine is equal to opposite over hypotenuse, right? The co-op, the CAF, let's write this.
Yes.
That's cos is adjacent over hypotenuse, right? So it's just a word to help me remember all the ratios. So sine, so means opposite over adjacent. Ka is cos is adjacent over hypotenuse. And finally, toa is tan is opposite over adjacent. right? So that's where we got SOHCAHTOA from. Just to help you remember those ratios. Okay? Any questions?